Hey everyone, how's it going? Hope your day is going well. So, today we are going to convert from moles to mass and from mass to moles. And if you notice over here, I have in the picture a little mole. He looks kind of like an avocado. It's kind of cute. The reason I like this image is because you have the mole and you could see how it relates to particles, all right? And how the mole also relates to mass. And that's what this part is about, moles to mass and mass to moles. So when it comes to this section, what you need is your periodic table, and what you're also going to need is a calculator. So make sure you have those handy. Calculate. So you have those handy when you are doing these problems. Now on this slide, notice I do have my calculator, and I have up here something called the molar highway. And so this is something that you could have as part of your notes to help you keep track as to where is the problem. What is it that it's asking for, and where is it that you're going? So in this one, this is where the particles are. So if we start with particles, our conversion factor to go from particles to moles, you need to use Avogadro's number, which is 6.02 times 10 to the 23rd. Now, if you're going from particles to moles, you are going to follow the top arrow where you're going to divide by that number of 6.02 times 10 to the 23rd. If you're going from moles to particles, you are then going to multiply by that number. Okay, so that was the last lesson that we were at. This one is now where we're going from moles to mass. And when it comes to that, when we're going from moles to mass, we need to multiply by the molar mass of that object that we're dealing with. I don't want to call it an object, but that chemical that we're dealing with. And if we're going from mass to moles, then we're going to divide by it. So I have the problem here. How many moles are in 15 grams of lithium? So when it comes to this, I'm going to rewrite what was given to me in the problem. So we have 15 grams of lithium. But what is it that we want? We want moles. So that means we need to look up, in this case, since lithium is an atom, we need to look up the atomic mass of lithium. And when I look that up, that number is 6. Lithium's over here. I know you can't really see it, but when you look at your periodic table, it is 6.04 grams of lithium per 1 mole of lithium. Now notice the number 1 is associated with the mole in a conversion factor. Also making sure that your grams cancel out and you're left with the unit you want, moles. When you plug it into your calculator, you're going to get an answer of 2.48344, etc., which we then have to round to sig figs. Yay, Mrs. Z, I love sig figs. But how do I figure out the sig figs? Glad you asked. We see here we started off with 15, the number 15, 2 significant digits. So I'm going to round this from 2.4. Now, does that make sense? Not quite, because as you learned in math, you have to round and look at what's the number after it. So it's going to be 2.5, not grams, but it's going to be moles of lithium. All right. All right, so what about when it's a compound? So it's the same concept, but in this case, we're going to go from how many grams of a material to how many moles of that. So notice again, we're starting in grams, and we're going to go to moles. So we're going to follow this bottom line where it says we're going to divide by the molar mass. All right, so before we do anything, let's figure out for sodium and for fluorine what the molar mass is. Sodium is 22.99, and there's one of them. And there's 19.00 times 1. Yes, ladies and gentlemen, please make sure you have those zeros. So we have 22.99, 19.00, and we end up with a fabulous number of 41.99 grams per mole. So now we're going to take this number and compare it to 4.5. So as always, start with the number that is given in the problem, 4.5 moles of sodium fluoride. Now we need to use the conversion factor of the molar mass. So if you notice by the units, the way that they're set up, it's already grams per mole, right? And that's what we want. We want to get rid of the mole. How many moles are there? 1. For every 1 mole of sodium fluoride, you have 41.99 grams of sodium fluoride in theory. All right, so now we're going to cancel out those moles. Multiply 4.5 times 41.99, and you end up with 188.955 grams of sodium fluoride. Now, remember, we need those sig figs. In this case, again, look at the number we started with, 4.5. That's 2 sig figs. So we're going to take this number and make it into sig figs, right? So there's an 8, and we're going to round up. Now, if you just put 19, it's wrong. 19 is not the same value as 188. It's actually 190 grams of sodium fluoride. If you gave me an answer of 189, that's okay too. So ladies and gentlemen, how will I know that you watched this video? Did you write down the molar highway? So please write down the molar highway. You're allowed to reference back to that. It is a very helpful tool, and I hope you get to use that. As always, if you have any questions, please contact me, and I'm happy to help you guys. Miss you all. Take care. Bye.